Whoops. All right, let's just start with the book page stuff first and see if we can answer some of those questions first. What questions do you have from the textbook? 14. That's the first number I heard, so that's the first one we're going to do. All right, somebody's going to have to read it. Wait, hang on, let me kind of get going here. Let me zoom in up there so y'all can see. All right, 14. Somebody tell me what it says.
2 times radical 3 sine of 2x.
Wait, 2 times radical 3
Sine of 2x
sine of 2x
equals radical 3.
equals radical 3. And what's the interval that we're allowed to do here?
0 to 2 pi.
0 to 2 pi. Now, it's always nice when we can make these problems where we don't have the double angle or the half angle, but you don't always get that opportunity to do that. On this one, I don't think this is one where we're going to be able to do that. I do want to get this little guy by himself. How are you going to do that?
Divide by 2.
Divide by 2 radical 3. She's got it, because it means 2 times radical 3 times sine of 2x. So if I divide both sides by 2 radical 3, what's that going to give you on the right-hand side? Half. Now, in your mind, you can sort of think of, let me grab a little highlighter or something. You can think of this 2x, if it freaks some of you guys out to see that, just kind of think of that as a theta for now. Forget the double angle piece. And theta, sine of what, is a half? Let's think about this. That's a positive half, so it's going to be in the first quadrant. 1 over 2, so that's 1, 2 radical 3. What angle is that? 30 degrees, right? Which is pi over 6. But sine is going to produce a positive answer also in quadrant 2. And we know that this is pi over 6. You just said that. If the whole way to there is 6 pi over 6, then take one off and we've got 5 pi over 6. Now here's the thing. This isn't really theta. This is 2x. So we've got to do two things. We're going to change this to a 2x, and it means that this interval is going to change. We're going to double everybody. So 0 times 2 is 0, x times 2 is 2x, and 2 pi times 2 is 4 pi. So this double angle, we need to keep going until we get to 4 pi. I've only got till 2 pi. So we need to take pi over 6, and we're going to add a whole 2 pi, a whole circle, to get us back where we started. So if I add 2 pi, it's like adding 12 pi over 6, that's going to be 13 pi over 6. And if I take 5 pi over 6 and add a whole 2 pi, that's going to be 17 pi over 6.
Do we need to do that if it had to be between 0 and 2 pi?
It's not. The double angle would be between 0 and 4 pi.
Well, I mean, the original thing was...
But this isn't the original thing. This is 2 times x. You see what I'm saying? So we're about to divide everybody by 2. Divide by 2 means multiply by a half, yes? So we wind up with, that's going to become pi over 12. This one becomes 13 pi over 12. This one becomes 5 pi over 12. And this one becomes 17 pi over 12. And all of those answers, Jonah, for x, all 4 of those fall within 0 to 2 pi.
Where did you get it?
I multiplied everybody by a half. Because Caitlin, I had to divide everybody by 2. Everything is multiplying by a half. So the bottom number all changes to 12. Good question. Anybody else questions on this? All right. Give me another one from the textbook.
22.
Okay. What's it say, Catherine?
Where do you want to get x over 2 equals cosine x over 2.
Equals what? I'm sorry.
Cosine x over 2.
Well, these things are always easier if you can get them so that there's only one trig function. Can I do that? How can I make that so that it's all the same trig function?
Well,
Can we change?
yeah, or we could say...
Oh, yeah, we can totally change the x to secant. This is going to be a good video. All right. We've got 1 over cosine of x over 2. Sorry. Nice catch. I always do that. I read that too fast. Isn't that what secant of x over 2 means?
Yeah.
Same thing, right?
Maybe
Now what do we do?
multiply, yeah.
Yeah, let's multiply both sides by cosine of x over 2. So now I have cosine squared of x over 2. How do you get rid of this little 2? Square root, right? Yeah, we can get rid of that little 2 if we take the square root of both sides. If you take the square root of both sides, what do you have to remember? Plus and minus. So the square root of 1 is 1, but it could be positive, could be negative. Now what's the interval on this, Catherine?
X.
0 to 2 pi. Notice we weren't able to get this little half angle to just be a regular old x, so I got to half everybody up here. So we need all of our answers to fall between 0 and pi for x over 2. So I've got two equations here. One of them says that cosine of some angle is 1, and one of them says cosine of some angle is negative 1. Think about cosine and where it's positive and negative 1. It's positive 1 over here at 0, right? So the angle x over 2 could be 0. Is it positive 1 anywhere else? Nope. This angle, cosine of some angle, is negative 1. We'll see cosine is negative 1 at, back here at pi. Both of these answers fall within our corrected interval. So now how do I get x by itself down here? Multiply both sides by 2. So I have x equals 0 and x equals 2 pi. And those, do they fall within this guy here? Does 2 pi? This doesn't say equal to. So it's just 0. Questions? Because it just said x over 2, so to get x by itself, multiply both sides by 2. Yep, good question. Anybody else? Do you want to move on? 35? Okay. 34, just kidding. 34. All right, Jesse, what's it say?
Sine of 2x equals 2 cosine squared x.
And what's my interval?
0 to 2 pi. No. 0 to 360.
0 to 360. Okay, degrees. Okay. Okay. I'm thinking two things. I would love it if I could just have x here. I would also love it if I could just have sines or just have cosines. A couple of ways to approach this, and either one, they're about the same length and number of steps. Do you guys want to try to get just x's, like for the angle since there's no double angle, or do you want to try to just get all cosines or all sines? Say again, Lewis? Sines and cosines. Okay, so if I want everybody to be sine, can I do that with him? Isn't there a Pythagorean identity that does that? You know what, even as I say this, I'm wondering if this is going to work. You know what? It's actually not going to save us any time to do that right now. Let's do the faster version. Let's change this to 2 sine x cosine x, because Lewis, what is going to happen is if I do that now, I'm just going to end up having to fix this anyway. Well, Lewis didn't know that. I sort of thought ahead. Okay. Let's get everybody on the same side of the equation. I'm going to subtract 2x or 2 sine x cosine x from both sides. If this expression looked like that, what would you do? Yeah, you'd factor out a 2x, right? So what do I do on this one? There you go. So I'm going to factor out 2 cosine x. That leaves me with cosine x minus sine x. Now I've got one factor times another factor equals 0. So one or both of them equals 0. So let's set them equal to 0. So now I've got 0 equals 2 cosine x. Divide both sides by 2. I still have 0 equals cosine of x. And where is cosine 0? 90 and 270. And both of those fall within our little interval range that they gave us. We've got this other guy we got to deal with. So we set cosine of x minus sine of x equal to 0. Okay, somebody says add sine of x to both sides, so let's do it. Now what?
Divide by cosine.
Okay, and he is fine in doing that. You can divide both sides by cosine of x. Be very careful though, because what happens on the left when you divide by cosine of x?
Equals
It does wind up over here, but you're kind of starting to cancel out things that have x's in them. Sometimes you lose a solution that way and it disappears, and you wouldn't know it unless you've looked at it on a graph. So be really careful about that. We've got a 1 here, and that equals tangent of x, yes? So tangent of what angle is going to give you 1? 45 degrees. What else? Tangent's positive in the first quadrant, but also in the third quadrant. So if that reference angle is 45 degrees, we're at 225 degrees. So it looks like we've got 4 answers here. Questions? If you were nervous about losing solutions over here, instead of dividing both sides by cosine, what you could have done is you could have squared both sides. And yes, I realize sometimes that does produce extra solutions and you have to check it at the end, but at least you'd know for sure you didn't lose solutions. You may have gained an extra that doesn't belong there, but one wouldn't disappear. So if you square both sides, then you could use the Pythagorean identity and make them all the same trig function. Okay, does everybody understand? Yes, ma'am.
Is there instructions to find all solutions?
Oh, it did? I'm sorry. I did not know that. I thought the interval was here to here. Does it say all solutions? Okay, so if it says all solutions, let's look at this whole tangent business down here. Here's 45 degrees, and it looks like 180 later, we have the same answer. 180 later, same answer. 180 later, same answer. So for this one, we're going to say 45 degrees plus 180 degrees in. So that's that one. For cosine, is 90 and 270 180 degrees apart? Same deal. So you're going to say 90 degrees plus 180 degrees in. So every 180 degrees, one of those are just going to pop up. So those are your 2 answers. Thank you, Melanie. Other questions on the textbook? 38? And then how about after this we move to the worksheet? Is that okay?
It is.
All right, 38. What's it say? 4 cosine 2 theta
Equals 8 sine theta cosine theta.
equals 8 sine theta cosine theta. What do you guys want to do first?
Take out the 4.
Yeah, that 4's kind of driving me crazy. Let's get rid of that. So if you divide both sides by 4, we have this. Ah, what's that called?
The sine thing to sine.
Yeah. It's a double angle identity that he recognized. Now hang on, before we get too much further, tell me my interval. What am I supposed to solve for? All solutions? Okay, just checking. Okay, now what?
Negative divide by cosine.
Okay, let's try it. Divide by cosine of 2 theta. Is this the only way to work this problem? No, there are multiple ways to work this problem.
There are 10 ways to this.
Exactly 10, you figured that out? All right, so this is just representing some sort of angle. So tangent of what angle is 1?
45 degrees.
45 degrees? Where else?
225.
Right, also positive at 225 degrees. And those equal 2 theta apiece. So what are we going to do with those?
You just have to work it divided by 2.
You got to divide them by 2. So I have 22.5 degrees. And what's half of that?
112.
But it's asking for all solutions. Are these 180 degrees apart?
There.
I don't know.
They're not, are they? So we're going to say this guy plus 360 degrees times n, and this guy plus 360 degrees times n. And that should get us our answers. However, I worked that a different way, and what did I get? Do we have an extra solution?
I bet it's
We're going to square both sides. I think before we lost a solution. Somehow when I worked this out, I only wound up with... Oh, because I didn't do positive, negative. Never mind. I did it a completely different way. I got the same answer. We're good. Okay. So there's 38. Alrighty? Alrighty, let's move on to the worksheet. Grab that worksheet. Alright.
Number 12.
12 it is. What's 12 say?
12 says 2.
Cosine. 2 cosine squared theta is 3 sine.
Equals 0?
Yeah.
What's my interval?
0 to 60.
0 to 360. This is worksheet number 12. Okay, it'd be super awesome if I could get those trig functions to all be 1. How can I make them match? Or can I? Not yet. Can't you make this signs? Pythagorean identities? The early identities we learned. Doesn't this equal 1 minus sine squared theta? Yeah, let's do that. 2 times. Do what, hun?
You have to distribute them.
Right, we're going to distribute. Great response. So we distribute. Now I have 2 minus 2 sine squared theta plus 3 sine theta equals 0. And this wouldn't look so bizarre if it were in a different order. So I'm going to put everybody on the right-hand side of 0 because I want this negative 2 to be a positive 2 sine squared theta so that I can get ready to see if I can factor this guy. Because that is a quadratic equation. Y'all with me? Do what? Yeah, it does look nice. Is this factorable? Let's try it. So we have 2 sine theta and sine of theta, because 2 times 1 is 2. The only way to get this 2 in the back is a 1 and a 2 or a 2 and a 1. If I made this one a 2 and this one a 1, if I had negative 4 sine theta plus 1 sine theta, that gives me negative 3 sine theta, so that does work. Once you have factored, set them both equal to 0, yes?
Yes.
So 2 sine theta plus 1 equals 0. Sine theta minus 2 equals 0. The guy on the left, does it freak you out if I do 2 steps in 1? Can I just say that that equals negative a half?
Yeah, or does that work?
Because you subtract 1 from both sides and divide both sides by 2. Is everybody okay with that?
Yeah, that works. Yeah.
All right. It looks like the answer to this sign problem is negative. What quadrant does that put us in? 3 and 4. If you need to draw the triangles, you can. Sine is opposite over hypotenuse. Oh, it's one of those 1, 2 radical 3 ones. 30 degrees, right? So pi over 6 is going in. Oh, wait, we're in degrees. Just kidding. So if this is 30 degrees here, what's that angle? 210. And then you also said the fourth quadrant, and you told me this was 30 degrees. So what angle is that right there?
330.
330 degrees. So there's those guys. How about this over here? We're going to have sine of theta equals 2. What do I do with that? Say again, Jessica? It's not even an answer. Like, you can't do that. Sine bounces back and forth between -1 and +1. This is outside the range of what sine is allowed to be. There is no solution for that, so just cross it out. So you have 2 answers. That one freaked everybody out. All right, worksheet. Another one. Give it to me. This is my last one, probably. 20. All right, somebody read it.
6 sine squared theta plus 5 sine equals 6.
All right, I'm seeing some kind of quadratic going on here. And I love that I don't have double angles or half angles. I don't have to mess with those. I love that they're the same trig function. I love that. So let's just turn this into a quadratic equation. So I have 6 sine squared theta plus 5 sine theta minus 6 equals 0. It's probably factorable. Pretty sure we're going to use 2s and 3s. That's 2, that's 4, if that's 3. 6 and 6. If that's 2 and 3, that's 9, and that's 4, that'll work. So I need a positive 9 and a negative 4. Okay. There's your 2 factors. Set them both equal to 0. So I have 2 sine theta plus 3 equals 0, and 3 sine theta minus 2 equals 0. On the left, I have sine of theta equals, I'm going to do 2 steps in 1, that's -3/2. You with me? And on the right, I'm going to go ahead and break this one down as well, and I get positive 2/3. Now, why was this one hard? Why can't I just finish this out? Do we know any angles that are going to give us -3/2? I don't. This is one of those ones that's going to take a calculator.
2 decimal places.
Right, and it says it's solved in 2 decimal places. Okay, so let's check this out here. Do we need to be in radians or degrees?
Probably degrees.
Does it tell you radians or degrees on
It
that?
says 0.
Then we need to do radians. All right, then we're going to, it says 0 to 360 degrees? 0 to 90 degrees? Oh, terrific. So on the left, do I even have to mess with that?
No.
Sine is positive from 0 to 90. So that's not even a, you're going to have to mess with that. Don't waste your time.
No one's added.
2/3. Inverse sine of 2, oh, I forgot to check my mode. We're in degrees, right? Is that what we're supposed to do? It says to give the answer in degrees? Yes?
Yeah.
Okay. So, inverse sine of 2/3. And we have 41.81 degrees.
Why did you
Say again, I'm sorry.
why did you do that?
Because I don't know what angle is 2/3. I had to actually plug it in. So anytime, Caitlin, you're looking for the angles, you are doing arc sine in your head is what you're doing. Yeah. And that's obviously going to be the only one from 0 to 90. Does that make sense? Yes? Okay, are we a little bit clearer on some of this? Okay, and you guys are going to watch videos for 3rd and 4th hour, and hopefully they'll ask different questions, right?
Yeah.
Okay, terrific. Let me turn this off.